Good morning, all of you. Welcome to Sri Jayendra Rank Zone. Now we are in second lecture of coordination compounds. In the first lecture, we have done how to write name of the coordination compounds. Now in this lecture, we are going to discuss about isomerism and some questions related to coordination compounds as well as isomerism. So isomerism in coordination compounds. Now in this lecture, we are going to discuss. Listen carefully. This is also an important topic. And from coordination compounds, definitely you are going to get one question for entrance exam. Minimum 2-3 questions you will get. It's very, very important chapter for NEET as well as JEE means. So please listen carefully. Now, isomerism in coordination compounds. So the compounds having same molecular formula but different structural formula are called isomers, and the property is called as isomerism. So the compounds having same molecular formula but different structural formula are called isomers, and the property is called as isomerism. So isomers are nothing but two or more compounds that have same chemical formula but different arrangement of atoms. So they are nothing but what? They are having same chemical formula, that is molecular formula, chemical formula, but a different arrangement of atoms. Two principal types of isomerism are known among coordination compounds. So the coordination compounds also exhibit isomerism. Isomerism means having the same chemical formula but different arrangement of atoms. So that is called isomerism. Now let us continue now. Next concept. So isomerism, it has two types of isomerism mainly. Structural isomerism as well as stereoisomerism. In structural isomerism, you will be getting ionization isomerism, solvate isomerism, that is also called as hydrated isomerism. Next, linkage isomerism, coordination isomerism. And in stereoisomerism, geometrical and optical. So definitely you will expect a question from these isomerisms. They'll ask the compound here shows which type of isomerism. So it has ionization. Isomerism is broadly classified into two categories. One is structural isomerism, another is stereoisomerism. In structural isomerism, you have ionization isomerism, solvate isomerism or hydrated isomerism, that is linkage isomerism, third one, and fourth one we have coordination isomerism. And in stereo isomerism we have geometrical isomerism as well as optical isomerism. So from all these examples are very important. Definitely they are going to ask questions in the entrance exam. So please listen carefully the definition as well as examples. And after finishing this class, you will be able to answer the questions based on isomerism. So let us start now. Let us start now. Ionization isomerism. The complexes having same molecular formula but give different ions when dissolved in solutions. They will give different ions when dissolved in solutions are known as ionization isomers, and the phenomenon is called as ionization isomerism. This isomerism arises due to the counter ion, that is ion in ionization sphere can become a ligand by displacing a ligand which becomes a counter ion. So here the counter ion and the ligand are important. So let us see the example so that you can understand it in a better way. So the complexes having same molecular formula but give different ions when dissolved in solutions are known as ionization isomers, and the phenomenon is called as ionization isomerism. So let us see now examples for this. So example you can see here, cobalt tetramine bromine. So you can say amine. So tetramine bromido cobalt sulfate. So here's a cobalt to sulfate. This oxygen state of cobalt is +3. So cobalt to sulfate and cobalt 3 sulfate. And here pentamine bromo. So here the ligand is in this coordination entity, ligand is bromine, and in this the coordination entity, the ligand is sulfate ions. So just this is nothing but example for, so bromine will go outside and sulfate will come inside for the second isomer. So here it is, actually this should be 4 only because it will not change the compound. So see CO NH3 taken 4 times, BrSO4, CO NH3 taken 4 times, SO4 taken bracket, and Br. Give different ions in aqueous solution. These complex cannot be differentiated by adding silver nitrate solution. So the second complex gives a yellow precipitate of silver bromide, while the first complex does not. So this complex will not give precipitate with silver nitrate solution, where the second complex will give precipitate because bromine will form silver bromide solution, due to which the precipitate of silver bromide is formed while the first complex does not. Means here, if you take this cobalt tetramine means this is tetramine, and here bromine will be there inside the coordination entity, and sulfate. So this is now when this treated with silver nitrate solution, silver nitrate solution, what happens? No precipitate is formed. No PPT, precipitate is formed. Whereas for the second one, if you do the same formula but different arrangement of atoms, because in the coordination entity, sulfate ion will come and outside bromine will be there. So this bromine ion combines with silver nitrate and forms silver bromide precipitate plus this complex compound, that is CONH3 taken 4 times SO4 inside, and outside we have nitrate ion, that is NO3 minus ion. So this is nothing but the complex. So they are having same molecular form, same chemical formula, but when they are dissolved in different solution, that is silver nitrate solution, one will form precipitate and another will not form no precipitate. So this is called as ionization link isomerism. This is called ionization isomerism. So I hope it is clear now. So this is called ionization isomerism. In this type of isomerism, they will give different ions in aqueous solutions or in other solutions. So these complexes can be differentiated by adding silver nitrate solution. This is very, very important point. So ionization complexes can be differentiated by the means of adding silver nitrate solution. The second complex gives yellow precipitate of silver bromide. This is yellow in color, yellow color. This is silver bromide forms due to silver bromide precipitate. And while the first complex does not give any precipitate, no PPT. So this is called isomerism in coordination complex. That is called ionization isomerism. Ionization isomerism, very, very important. So which type of compounds will go ionization isomerism? How to remember ionization isomerism? So the gift they are, when they are dissolved in the solution, they'll give different ions. When they dissolve in solution, they'll give different ions. So to test ionization isomerism, these complexes can be differentiated by the adding silver nitrate solution. These complexes can be differentiated by adding silver nitrate solution. So here in this case, bromine will combine with silver nitrate and form silver bromide yellow precipitate, whereas sulfate will not combine with silver nitrate. So this complex will not have give any precipitate for this. So I hope it is clear. Next continuation. This is the first type of isomerism, that is ionization isomerism. It will come under structural isomerism. Next we have solvate isomerism or hydrated isomerism. So this is also known as hydrated isomerism in case where water is involved as solvent. If the solvent is water, we can use hydrated isomerism. If water is not solvent, we will say simply it is solvate isomerism. This is similar to ionization isomerism. So in this case, what happens? The complex is having same molecular formula, but different number of water molecules in and outside the coordination sphere. These isomers differ whether they are by whether or not a solvent molecule is directly bonded to the metal ion or merely presented as free solvent molecules in the crystal lattice. For example, you can see here chromium. This is hexa aqua chromium 3 chloride. Hexa aqua chromium 3 chloride. This is aqua complex, violet in color, whereas this is called penta aqua, one water is outside the coordination entity. You can see here in this compound, one water molecule. Here only 5 water molecules are present. This is penta aqua, and one water molecule is outside the coordination entity, that is coordination sphere. So as the one water molecule is outside the coordination sphere, only water. So this is called hydrated isomer. So solvate isomer is gray color green. So gray, green, and violet. The colors also will change. So this type of isomerism is called as solvate isomerism or hydrated isomerism. So the complex is having same molecular formula but different number of water molecules in and outside the coordination sphere. Number of water molecules is same. Here total it is 6. Here also 5 plus 1 it is 6. As the number of water molecules are same, but the element of water molecules is not similar in first case and second case. One water molecule came outside in the second case, and all the 6 water molecules are present inside the coordination entity in the first case. So that's why this is nothing but solvate isomerism. And due to the presence of 6 water molecules in the coordination sphere, this complex is violet in color. And due to the presence of 1 water molecule outside and 5 inside, this complex is gray and green color. So they are showing different colors. So that's why. And the formula wise, if you see, it's same. The formula is same in both the cases. Here Cl3 should be there. Here Cl3 should be there and H2O should be outside. So formula will not change. Only the same molecular formula is very important. Here 3 is not given properly. So here I have written 3. So it is Cr H2O taken 5 times Cl3 coordination entity, that is square bracket. Outside we have 1 water molecule. So this is called solvate isomerism or hydrated isomerism. This type of isomerism arises due to the arrangement of water molecules, due to the arrangement of solid molecules. So these isomers differ by whether or not a solvent molecule is directly bonded to the metal ion or merely present as free solvent molecules in the crystal lattice. So this is called as solvate isomerism or hydrated isomerism. Both are same. I hope it's clear. Next continuation. Next, we have linkage isomerism. Third type of structure isomerism, it is called as linkage isomerism. This isomerism is found in complexes having ambidentate ligands. Very, very important. Ambidentate ligand means which have two or more centers. Two or more centers means the electron donation can be done. You can say here, for example, ambidentate ligand means here they can be as what are ambidentate ligands? Ligands having two donor atoms. If they have two donor atoms, the donation can be done from either one atom. So it is nothing but two donor atoms, two or more donor atoms, you can say. Maximum it is two, like in the case of cyanide, Cn minus, and isocyanide, Nc minus. So donor atom here, nitrogen, and here it is carbon. So this is nothing but ambidentate ligands. The isomers having same molecular formula but differ in the donor atoms of ligand, as I told you, as they are having two or more donor atoms. So donor atoms, the electrons will be gained by the metal, a central metal atom by different donors are known as linkage isomers. They are called as linkage isomers. Let us see now continuation. Examples. Examples of linkage isomers you can see here. CO NH3, how many times? 1, 2, 3, 4, 5, 5. And here NO2. That is the linkage. The nitrogen is donating its lone pair of electrons to cobalt. So this is called ligand. This is called what? Ligand. Here the donor atom is nitrogen. And here the donor atom is oxygen. So that's why we will say nitrito-N. Nitrito-N. I just write it clearly. This is called as nitrito N isomer, and this is called as nitrito O isomer, because the from oxygen it is going, the electron to pair is donating. So nitrito N, nitrito O, the linkage will be like this. If nitrito N is there, so it is directly cobalt, the central atom is linked to directly nitrogen. If nitrito O is there, the cobalt is linked to oxygen atom. Here this cobalt is linked, the central metal atom is linked to oxygen atom. So this is called, what is the name of this compound? 1, 2, 3, 4, 5 amines are there. So the formula of this compound is CO NH3 taken 5 times NO2 plus 2. So plus 2 means the oxygen state of cobalt is plus 2. So here this is the thing here, 1 NO2. So this is the name of this compound, is the formula of this compound is same. This is also the same formula. And here this name of this compound is pentaamine. Pentaamine cobalt. So here nitrito N cobalt 2, nitrito N cobalt 2, and this is called pentaamine nitrito O cobalt 2, nitrito O cobalt 2. So cobalt 2, I'll write it clearly. Cobalt 2. Cobalt 2. So this is pentaamine nitrito N cobalt 2. This is pentaamine nitrito O cobalt 2. This is nothing but linkage isomerism. This type of isomers are called as linkage isomerism. Very, very important. So please note down. This is called linkage isomerism. Linkage isomerism. So where the ligand should be, definitely it should have ambidentate ligands. So if you see the examples of ambidentate ligands, automatically you'll understand this is ambidentate ligands, where it has the electron donors can be done by two atoms. So in this case it is nitrogen, electron is donating from nitrogen atom, and in this case it is electron donor is nothing but from oxygen atom. So that's why it is called nitrito O, and this is called nitrito N. Very, very important. So this type of isomerism is called as linkage isomerism. This type of isomerism is called what? Linkage isomerism. Next continuation. So this is CO NH2 taken 5 times, NO2. Cl2 is also kept outside. Cl2 we don't have in here. Just they have given only coordination entity of this. So only entity. Cl2 is outside. So outside means chloride. We'll simply write Pentamine nitrito N cobalt 2 chloride. Pentamine nitrito O cobalt 2 chloride. If you take chlorine also into consideration, so chlorine will be outside, so chloride. Chlorine will be outside, so we will write it as chloride. So what is the name of this compound? I'll write here clearly. The name of this compound is pentamine, pentamine nitrito N, nitrito N cobalt 2 chloride, cobalt 2 chloride. And the other one will be for this one it is pentamine, pentamine, because 5 amines are there, nitrito O, nitrito O, cobalt 2 chloride. So cobalt 2 chloride. So this is called example. So the linkage isomer of pentamine nitrito and cobalt 2 chloride is they can answer question also. The linkage isomer of pentamine nitrito and cobalt 2 chloride is pentamine nitrito O cobalt 2 chloride. Pentamine nitrito O cobalt 2 chloride, because it's already nitrogen. So here we will get the donor atom is oxygen atom, and here the donor atom is nitrogen. This is clear, very, very important. So please note down in your classwork. Next, continuation. So we have done three isomers: solvent isomerism, linkage isomerism, and ionization isomerism. Next, we have coordination isomerism. This isomerism is found in complexes. This isomerism is found in complexes where both cation and anions are complex ions. Very, very important. Cation as well as anions are complex ions. This type of isomerism arises due to exchange of ligands. Exchange of ligands takes place here between cation and anion of coordination pairs of different metal ions present in the complex. So this is nothing but CONH3 taken 6 times, CrCN taken 6 times. So this is anionic complex, this is cationic complex. This is cationic complex, and this is anionic complex because Cn is taken 6 times is there. So exchange, this can be done as CONH3 taken, COCN taken 6 times, and CrNH3 taken 6 times. So the ligands have been exchanged. With cobalt, ammonia is there, with chromium cyanide is there, and here with chromium ammonia has come, and with cobalt cyanide has come. So this is anion and this is cation, cationic complex. So this type of isomerism arises due to exchange of ligands, and this type of isomerism is found in complexes where both cation and anions are complex ions. Where cations and anions are complex ions. This type of isomerism arises due to exchange of ligand. So with cobalt, amine is the ligand, and with chromium, cyanide is the ligand. And here with chromium, amine has come, and with cobalt, cyanide has come. So this is the nothing but example of coordination isomerism. What is this example? This is called as coordination isomerism. So this is about isomerisms: ionization isomerism, hydrated isomerism, linkage isomerism, and coordination isomerism. All the four types of isomerism we have done. More about examples of this we'll discuss now, so that we can go for geometrical and optical isomerism. That is, so this is up to stereoisomerism we have done. That is structural isomerism. Now we'll do next concept in this. Next we have stereoisomerism. Stereoisomers have the same chemical formula and structural formula, but they differ in spatial arrangement. Here, this is called spatial arrangement of atoms or groups. This is called as stereoisomers. It is of two types. One is geometrical and another is optical. As we already know, it is of two types. One is geometrical and another is optical. So let us see now geometrical isomerism. This type of isomerism arises in heteroleptic complexes. First, we know what is heteroleptic complex, where we have different ligands attached to the metal. So that is called heteroleptic complex due to different possible geometrical arrangements of the ligands. Complex with metals having coordination number 1, 2, 3 do not show geometrical isomerism. Very, very important point. If the coordination number of the metal is 1, 2, or 3, it will not show geometrical isomerism. Apart from above that, only it will show geometrical isomerism. Next, continuation. The complex can have either tetrahedral or square planar geometry if the coordination number is 4. As we already know, the complex have the same. The complex have the either tetrahedral shape or square planar. Either tetrahedral shape or square planar geometry if the coordination number is 4. The square planar complex can only show geometric isomerism. Tetrahedral will not show. Only square planar complexes will show geometric isomerism. The type of square planar complexes which can show geometric isomerism are, it is of the form Ma2B2. Please note down this form so that you can identify Ma2BC, MABCD, MABCD. So this type of isomerism is exhibited by the compounds which are square planar complex of the type Ma2B2, Ma2BC, MABCD exhibit geometrical isomerism. Example, you can see Ma2B2, Ma2B2. For example, a complex of the type Ma2B2. For example, this is nothing but platinum, NH3 taken twice. This is A2 and B2 is Cl2. So this have square planar complex and it will show geometric isomerism. Example, we can write the same as platinum NH3 similar type, MH3 on the same side, and Cl on the same side of other side. So this is called cis isomer. If similar groups are present on the same side, it is called cis isomer. This is called what? Cis isomer. And if similar groups are present on the opposite side, this is NH3, this is NH3 one side, Cl one side, Cl this side, and NH3 this side. Simple it is. So this is called trans isomer. This is called what? Trans isomer. So cis form and trans form. So this is nothing but platinum. So what is the name of this compound? What is the name of this? Cis form is orange yellow in color and trans form is pale yellow in color. This is pale yellow, and this could be what? Orange yellow, and pale yellow. So please note down this also. Everything I'll write here, and if you so this is nothing but cis isomer and this is called trans isomer. The name of this compound, can you guess the name of this compound? This is amine, this is chlorine. So diamine dichloroplatinum 2. This platinum oxygen state is 2. So diamine dichloroplatinum 2. Diamine dichloroplatinum 2. Diamine dichloroplatinum 2 will exhibit geometrical isomerism. It has cis form. So cis form of diamine dichloroplatinum 2 is orange yellow in color, and trans form of diamine dichloroplatinum 2 will have pale yellow in color. So please note down the colors also, and we'll discuss all these things in the example. So one example I want to show here. So this type of isomerism having square planar complex which can show geometrical isomerism. If the complex can have either tetrahedral or square planar with coordination number 4. The complex is having coordination number 4 and having tetrahedral shape will not exhibit geometrical isomerism. If they have coordination number 4 and have square planar complex only, will exhibit geometrical isomerism. So the geometry should be square planar complex only. So please listen carefully. This is very, very important. Definitely you're going to get questions which type of isomerism the compound will show. They'll ask in the examination. So example, you can see cis isomers, same ligands are adjacent to each other, and trans isomers, same ligands are opposite to each other. And the cis isomer of this complex is orange yellow in color, orange yellow in color, orange yellow, and the trans isomer of this complex is yellow in color, pale yellow and orange yellow. And dipole moment is also, for this dipole moment is, for cis isomers, you know dipole moment exists. It is equal to 4.8 device. Whereas for this trans isomers, dipole moment is equal to 0 because oppositely the electrons will be pulling from this side and this side, this side and this side. So they'll cancel out each other. So due to opposite dipoles cancel out each other. As ligands are opposite each other, they cancel out each other. So the dipole moment is equal to 0 for this, and for this it is equal to approximately 5.8. So it is 5.8 device. 5.8 device. So dipole moment exists for cis isomers and no dipole moment exists for trans isomers. So trans isomer, it is spelling is isomer here, ISO. So you can check it out. This is a small mistake. So this is clear. So this is called as geometrical isomerism. Which type of molecules will undergo geometrical isomerism? Geometrical isomerism will be exhibited by Ma2B2. This is Ma2B2. Next we have MABCD. Similarly, we have M A B C D, M A to B to, and M A to B C. M A to B C. These are the square planar complex having geometrical isomerism. Next, we have square planar complex of the type MA to B2, MA to BC, and MABCD exhibit geometrical isomerism. And square planar complex of the type MA4, MA4, comma. This is also square planar complex only. MA3B, MA3B, comma. MAB3, MAB3, where M is called central metal atom. Do not exhibit geometrical isomerism. So please note down these points. Do not exhibit. Even though they have square planar complexes, they do not exhibit geometrical isomerism. Do not exhibit geometrical isomerism, and this will exhibit geometrical isomerism. Please make a note in your classwork. This will exhibit this will exhibit geometrical isomerism. Very, very important. Please note down. This will exhibit geometrical isomerism. So please make a note in your classwork so that you easily can understand since we are seeing in the video. So please note down this example. This is orange yellow in color, pale yellow in color, and the dipole moment exists for this, and there is no dipole moment because opposite dipoles cancel each other. So which type of compound? This is Ma2B2. This is a molecular type Ma2B2. Apart from this, MABCD, Ma2BC also will exhibit geometrical isomerism. And Ma4, the square planar complex having coordination number 4, are examples. Ma4, Ma3b, Mab3 do not exhibit geometrical isomerism even though the coordination number is 4 and it has square planar complex, but still they will not exhibit geometrical isomerism because they do not have cis and transforms. So please note it down, very, very important. Next continuation. So Ma2b2 or Ma2bc type is of Ma2bc exists in two isomeric forms, the cis form and I trans form. Next we have MABCD, total 4 different ligands, MABCD, MABCD. So this is nothing but total 4 different ligands. So this is nothing but complex of formula may exist in 3 different isomeric forms, MABCD. So A will be from this side, B will be this side, C will be this side, D will be this side. The same we can interchange as MACDB, MADCB. So they can represent in 3 ways. So that's why they are exhibiting trans isomerism, geometrical isomerism. The complexes with coordination number 6 will have octahedral geometry. Will have what type of geometry? Octahedral geometry. So the type of octahedral complex which can show geometrical isomerism are, apart from this, octahedral geometry also will show geometrical isomerism. Example, Ma4B2, Ma4BC, Ma3B3, MAAB2, where AA represents a symmetrical bidentate ligand. Symmetrical bidentate ligand. Complex of type and Ma4B2, Ma4BC exist in 2 isomeric forms. Ma4B2 and Ma4BC exist in 2 isomeric forms. So they will exhibit geometrical isomerism. So please note down all these types. So it's not so simple. That's why we should be thorough with all the types of molecules which show geometrical isomerism. So example you can see here, this is of type what? CO is the central metal atom. By seeing the structure also you can see this is CO, central metal atom, M, and this is Cl. How many are there? 2 are there. So Ma2, so Ma4B2. So this is 1, 2, 3, 4. 4 ligands of similar. So Ma4B2. This is of the type Ma4B2, where A is called amine, B is called chlorine. So this is the donor ligands are from chlorine and chlorine, and amines are neutral ligands is already in. This is called cis form. Similar groups are on same side, and here transform. Here similar groups are on opposite side. Opposite side. Only you have to check these two only. These two are adjacent, adjacent, and these two are opposite. Here we have opposite. So opposite side it is called trans, and adjacent side it is called cis. So what is the name of this compound? Cis tetramine cobalt 2 chloride. Cis tetramine cobalt 2 chloride, and this is called trans tetramine cobalt 2 chloride. Trans tetramine cobalt 2 chloride means the chlorine atom should be in opposite side, and cis means the chlorine atom should be in adjacent side. So you have to remember like this. This is called octahedral complex, showing it is not square planar. It is having coordination number 6 because 4 plus 2, 6 ligands are there. So coordination number is equal to how much it is? Coordination number is equal to 6 for both the molecules. And this is called cis and this is called trans. So this is nothing but geometrical isomerism of type MA4B2. MA4B2. So this is nothing but octahedral complex. Octahedral complex. And octahedral complexes will show geometrical isomerism. Very, very important. Please note down. So this is nothing but COO, NH3 taken twice, taken 4 times, Cl2 and bracket plus we have. So it is nothing but in the compound. Next, complex of type MAA2B2 and MAA2BC. These are also octahedral. In this type of complex, the monodentate ligand can be present opposite to each other or next to each other. The complex where the monodentate ligand present opposite to each other is known as trans isomers. As I told you, if monodentate ligands are opposite to each other, it is known as trans isomers. And if the monodentate ligands are adjacent to each other, it is called next to each other. That is adjacent. You can say adjacent. It is nothing but adjacent to each other. It is known as cis isomer. Very, very important. It's not so easy. So please listen carefully. Continuation. So you can see here bidentate ligands. We have En. So COEN taken 2 times Cl2 and outside it is plus charge. So if Cl are present here, these two are present adjacent to each other as chlorine atoms are present adjacent to each other. So we can say it is adjacent. So it is nothing but what? Cis isomers. And it is opposite here. So we can say here it is opposite. We can say it is trans isomer. So same compound with the trans isomer. So this is nothing but MAA2B2. MAA2, that is bidentate ligands 2 times B2. It has octahedral complex having trans isomerism and cis isomerism. So this is called MAA2B2 type. So this is called geometrical isomerism having octahedral complex. Having what complex? Octahedral complex. So please listen carefully. So COCl2 En taken twice plus is there. So COCl2 En taken twice. En2 means bidentate ligands 2 times. And for that the coordination number is 6. Octahedral complex of type Ma3B3. In this complex type, the geometrical isomerism is called as facial and meridional isomers in place of cis and trans. In facial isomers, the 3 ligands of the same type lie along corners of a face of the octahedron. 3 ligands of same type, you can see, please note down. And in meridional isomer, the 3 ligands of same type here, lie along the meridian of the octahedron, lie along the meridian and corners and meridian. So please listen carefully. Here, two important positions. One is corner, another is meridian. Let us see the diagram of it. So you can see here, amine are the 3, and this is facial because they are at the corners. They are at the corners. You can see 1 corner, 2 corner, 3 corner of the octahedral, and Cl are the corners. Whereas here meridional means here what happens? This Cl will be coming opposite, and here this is called meridional. This is called what? Meridional isomer, where we have like this meridional L shape. L shape means what? Meridional. You can see 1, 2, 3. And for this ligands, if you join, it will get L shape. L shape means meridional. So this is called meridional isomers, and this is called facial isomer. So having octahedral complex of type Ma3B3 having coordination number 6, having octahedral complex will have not cis and trans, will have facial isomerism as well as meridional isomerism. So A3, if the 3 similar ligands are presented along the corners, we can say it is called facial isomerism. Facial isomerism we have to see along the corners. And here meridional isomerism nothing but they are like this L shape. The similar atoms are present in L shape. It is nothing but meridional isomer. L shape means like this rectangular corner. Rectangular corner also you can say nothing but L shape. It's the best we have rectangular corners. So this is nothing but what? They are nothing but meridional. So this is of the type geometrical isomerism. This type of molecules will exhibit geometrical isomerism. Very, very important. Please note down. Clearly, we have indicated everything. 6 corners. And coming to this, these ligands are not to corners. They are having distance. So this is nothing but meridional. So CONH taken 3 times Cl3. This is of the molecule type Ma3B3. Ma3B3. Next continuation. So these are the different types of geometrical isomerism we have discussed so far. Now in the next session we will discuss optical isomerism. Now we'll see questions based on isomerisms and even naming of the compounds. Questions based on in the previous lecture we have not done naming of compounds. So now naming of coordination compounds. Apart from this, we'll do even questions based on isomerism in the next lecture we'll do. So now questions based on naming of coordination compounds is very, very important because in the first lecture, as it is for 1 hour duration, we do not have time to discuss more questions. Now we'll discuss more questions based on naming of coordination compounds. So if time permits, we'll do even naming isomerism also based on coordination isomerism and linkage isomerism, that is structural isomerism we'll discuss now. So let us see now question number 1 based on naming of coordination compounds. Yes, nomenclature. IUPAC name of question number 1. IUPAC name of K2 PTCl6 is, it is option 1 potassium. You have to see the options also so that you can understand how confusing they are. Potassium hexachloroplatinum. Hexachloroplatinum. Next, option B. Potassium hexachloroplatinum 4. Potassium hexachloroplatinum 4. In the oxygen state of platinum is 4. They are given. Next, option C. In oxygen state of the metal, you should write in Roman numeral. Next, we have potassium hexachloro. See how close the options will be. So you should know completely, then only you can keep the name easily. Potassium hexachloro platinate 4. Platinate 4. Next, potassium dipotassium hexachloroplatinum. Dipotassium hexachloroplatinum. So now you can guess the name. Now easily you can guess the name. Let us see now the name of this compound. So you can write now. So let us see now for answering this type of question. First of all, you should know potassium hexachloroplatinum is ruled out because we cannot have here no oxygen state of metal. So and fourth one also dipotassium. Dipotassium will not write, even though outside potassium 2 are there, we'll write only potassium only, as I told you already in the lecture. So answer it could be either B or C. How could we decide it is either B or C? First, we have to see whether it is cationic complex or ionic complex. By seeing this clearly, we can say it is nothing but K2P2Cl6. PTCl6 associates to form 2K plus PTCl6 taken 2 minus. PTCl6 taken. So this will form 2 minus, we cannot say here, just I love it. Solution I'm trying to say. So definitely this is minus here. So 6 PTCl6 minus here. So definitely this is anionic complex. What is this called? Anionic complex. For the anionic complex, the central metal atom should be end with 8. The central metal atom for anionic complex. Here I will add the hint. For anionic complex, if cationic complex is for anionic complex, for anionic complex, the central metal ion, central metal atom should end with 8. Central metal atom should end with 8, 80. So platinate 4. So answer is potassium hexachloroplatinate 4 is the answer. Potassium hexachloroplatinum 4 will not come. If cationic complex is there, the metal will have the same name. As this is not a cationic complex, this is anionic complex. You should know the reason also. That's why when you know the reason, definitely will apply the concept in the examination. So that's why for knowing the reason is very important. So for anionic complex, the central metal atom should be end with 8. As the central metal atom is ending with 8, we can say it is platinate, and the oxygen state of platinum is 4 here plus 4, because 2 plus 4 6, and 6 and 6 gets cancelled because 6Cl minus. So automatically we'll get potassium hexachloroplatinate 4. Potassium hexachloroplatinate 4. Why? Because for anionic complex, the central metal atom should end with 8. For cationic complex, the central metal atom will have the same name. That is platinum 4. Suppose if it is cation complex, this will come like this, platinum 4. As this is anionic complex, we'll have anionic complex, the central metal atom should end with 8. For neutral or cationic complex, the central metal atom should be written same. I hope you understood this clearly. So please copy down in your classwork. If you copy down, then only you can see the variety of questions. Otherwise, in the PPTs, we are not giving so many questions. That's why please try to understand. Next question now we have. They'll ask either the IUPAC name by giving the formula, or by giving the name, they'll ask us to write the formula. So both are very important. So let us see now. Second question number 2, based on this. The IUPAC name of, sorry, here the question number 2, IUPAC name of question number 2, IUPAC name of. Here I'm giving options because so that you can understand how confusing the options might be. Question number option A, IUPAC name of platinum NH3 taken 4 times, BrNO2Cl, BrNO2Cl. So this is a complex. Everything in bracket, and outside one Cl is there. Outside Cl we should not consider, only this only we have to write. After the complex name we have to write chloride. The name of this compound is option A, triamine chloro or chlorido bromo platinum 4 chloride. Bromo platinum 4 chloride. Platinum 4 chloride. This is very big name. So please try to understand. Option B. Option B, I'll write it properly. Triamine bromo nitrochloro chlorobromo platinum chloride. Here nitro is also there, the first option. Chlorobromo after nitro. Here also nitro. We are not included nitro. Nitro platinum chloride. Triamine bromo nitrochloro platinum 4 chloride. Platinum 4 chloride. See the options properly. Next option C, triamine bromo chloro nitro platinum 4 chloride. Platinum platinum 4 chloride. Please note the question. Next, triamine nitro chloro bromo platinum 4 chloride. So in all the cases, platinum fluorochloride is there, so we do not have to disturb. So straight away we have to see only this. That is nothing but ligands identification. So for amine, we'll have triamine. This is actually triamine and tetraamine. So NH taken 3 times actually. This is not 4 times, it is nothing but 3 times. Written question wrong. Is 3 times. So please note down. So triamine chlorobromo nitro-platinum 4 chloride. So platinum 4 chloride is common in all the cases. So no need to see whether it is cationic complex or ionic complex higher. Anyway, they are given platinum, the name of the metal as it is. So this definitely this should be a cationic complex. What is this card? Could be cat ionic complex only. So first it is clear it is cationic complex. Second thing we have to see, I'll write the solution here. Second thing we have to see arrangement of ligands. So ligands should be following alphabetical order. Ligands should follow arrangement of ligands should follow alphabetical order. Alphabetical order in the name. So alphabetical order we have to see now. So alphabetical order means for amines we'll get A, for bromo we'll get B, for nitro we'll get N, for chloro we'll get C. So definitely it should be A, M, C, B, N. So answer is third option. Triamine, bromo, chloro, nitro, platinum 4 chloride. So answer is C option because it is triamines, 3 amines, 1 bromo. So 1 bromo, 1 chloro, 1 chloro. Because after B we should get Cl and nitro N alphabetical order. So ligand should follow alphabetical order. The hint for this answer is ligand should follow alphabetical order. So I hope it is clear. Very, very important this type of questions. So please note down. Next we'll continue. Next question. So in this model number 3, how will you get? I'll do it. So please note down the at least hint you note down. Ligand should follow alphabetical order. So answer is C option. Next question. Question number 3. Model number 3. In case of naming of IUPAC compounds, tetraamine. Tetraamine. They'll give the name of the compound and you have to write the formula. Tetraamine diaqua tetraamine diaqua copper 2 hydroxide. Copper 2 hydroxide. Copper 2 hydroxide is given by the formula option A Cu NH3 taken 4 times, OH outside 2 times, dot 2H2O. Option B Cu NH3 4 times, dot OH taken twice, outside 2H2O. They are given outside. That is also important. And third option, Cu NH3 taken 4 times, dot H2O taken times, H2O taken 2 times, outside OH2, OH taken twice. And fourth one is option D, Cu NH3 taken 4 times, dot OH taken 2 times, H2O. So these are the 4 options. Now let us answer this question. I'll discuss this question now. They have given tetraamine, means amine should be 4. In all the options, amines are 4 times. And diaqua, water should be 2 water molecules, that is H2O taken 2 times. It should not be 2 H2O. And copper 2 hydroxide. Hydroxide should be outside. It can be any number. So since copper 2 hydroxide is given, hydroxide should be outside. Means OH should be outside the coordination entirety, because after metal oxygen state we have got hydroxide. So definitely this should be copper 2 hydroxide. This is cationic complex having hydroxide outside. Hydroxide outside means we have tried OH taken to its outside. So option is C here. Very, very important, since this is cationic complex and hydroxide is present outside. Then it can be 4 also, we cannot write 4 hydrox. So 4 hydroxide also. 2 aqua means diaqua means H2O 2 times, NH3 taken 4 times. So answer, it should not be 2H2O. If it is 2H2O, we have tried only water. That is copper to water. So that's why this is the answer. 100% is the answer. So third option. So this is the second model. It is tetraamine diaqua copper 2 hydroxide. Whenever they are given hydroxide outside, the anion complex, the anion outside means it can be any number of anions, but then only we'll write only hydroxide. We'll not write 2 hydroxide, that is dihydroxide. We'll not write dihydroxide, we'll write only hydroxide. Like the same case, if you, before the coordination entity, metal is present like K4 in the case of potassium hexaferrate, we'll write only one potassium, we'll not write 4 potassiums, that is tetra potassium will not write, we'll write only one potassium. So outside the coordination entity, whatever the ligand, either it can be positive ligand or negative ligand, they should be given only one number. The one number only, even though they are containing more than 2 or more than 3 or 4, etc. So that's why you can write outside the coordination entity. You can write the hint here, please note down. Outside the coordination entity, outside the coordination entity, the ligands are named only one. The ligands are named only single molecule, even though they contains only single, even though they contain more than one. So this is very, very important. So please note it down. More than one. So even though they contain dihydroxy, we'll write simply hydroxide. So I hope this is clear. So this is question number 3. Next, please note on this question. Next we'll see question number 4. So this is the model based upon isomerism. Sorry, not isomerism. This is nomenclature. So let us see now next question. Question number 4. So I hope you have copied it. We're clearing it off now. Next we'll see question number 4. Question number 4. Let us see now based on isomerisms. Now we'll see isomerism, or even this also we'll see, that is naming of complex compounds. The correct IUPAC name of platinum NH3 taken twice, Cl2 is, Cl2 also inside is. So option 1, diamine dichloro platinum, dichlorido or chloro, it is same, dichlorido platinum 2 is first option. Second option is another type of question. Diamine dichloro platinum 4 is nothing but platinum 4, means this is nothing. This is question based upon oxygen states. Next, third one, diamine, that is the option C, diamine dichlorido platinum 0. dichlorido, chloro or chlorido both are same, platinum 0. Next, fourth option, diamine, dichlorido, diamine, platinum 4. So this question is based purely on oxygen states. Easily by seeing the understanding, by seeing you can understand. So diamine dichloro is fine in both the cases. Diamine dichloro is there in all the cases. Diamine dichloro in all the cases. So we do not have to worry about ligands. We have to worry about only the oxygen state of metal here. This question is based upon hint is oxygen state of metal is important. Anyway, it is cationic complex, so it is oxygen state of metal is important here. So oxygen state of platinum, how to calculate? Since ammonia is oxygen state of platinum is, since ammonia is neutral ligand, ammonia is neutral ligand. So we will not consider this. So we can say x minus 2 is equal to 0 because 2 plus x plus 0 plus minus 1 into 2. Minus 1 into 2 is equal to 0. By this you can say x minus 2 is equal to 0. So it implies x is equal to plus 2 where x is called oxygen state of platinum. X is equal to plus 2. Sorry. Yeah, well, right. X is equal to plus 2. So it is nothing but platinum 2. Platinum 2. So answer is platinum 4 or platinum 2. So here, since two amines are there, so second option and first option we have to see. Second option, fourth option. So platinum 4, platinum 2. Diamine, dichlorido, platinum 2. So answer is first option. Answer is A, diamine, dichloro, platinum 2. It is not 4. So wanted they have given 4 two times. So answer is diamine, dichloro, platinum 2. So we have to see the oxygen state. So this is another type of question. Now, please note down this question. Next question we'll discuss. Question number 5. Question number 5. So I want to discuss more amount of questions so that you can see easily. Very, very important this one. IUPAC name of. This question is very, very important. IUPAC name of. IUPAC name of platinum NH3 taken twice, Cl NO2 is option A. It is platinum diamine chloronitrate, platinum diamine chloronitrate, chloronitrate. Option 2, it is chloronitritogen, chloronitritogen, amine platinum, amine platinum 2, platinum 2. Second option. By seeing the options, you can understand the question easily. That's why I'm giving option. Third option, diamine chlorido nitritogen, platinum 2. Next, fourth one, diamine chloro. Very, very important this question. Chloro nitritogen platinate 2. platinate 2. So this is also nothing but we have to identify whether it is cationic complex and anionic complex. Then oxygen state automatically you'll answer, you'll get the answer. So we have to see the question now. So it is cationic complex or anionic complex. So since platinum is in +2 state, so this should be definitely cationic complex. So cationic complex means platinum will come. Anionic complex means outside we have anion. So there is no. So answer now for this is since it is since the complex is cationic, complex is cationic, and ligand should follow alphabetical order. There is amine, chloro, nitro, N. This is NO2 is given, so nitro N. So answer is diamine chloride nitro N. Chlorido, sorry, this is chlorido. Diamine chlorido nitro N platinum 2. Answer is third option. Diamine chlorido nitro N platinum 2. This is diamine chloro nitro N platinate 2. So this is anionic complex. For anionic complex, we'll write since complex is cationic, we'll say platinum 2. And same question if they ask like this, platinum NH3 taken twice, Cl, ONO instead of giving nitro, ONO is. If they are given ONO like this, then we can say the name of this compound is very, very important. Please note down diamine chlorido, that is alphabetical order of ligands, chlorido, nitrito O, nitrito O, platinum 2. This is the answer. Platinum 2. So when they are given O and O, we have to write nitrito O. When they are given NO2, we have to write nitrito N. So please note down this change. NO2 means nitrito N. ONO means nitrito O. Because the donor atom is oxygen. Because this is an ambidentate ligand. Since nitrito is ambidentate ligand, so if the donor atom is nitrogen, we'll say nitrito N. If the donor atom is oxygen, we'll say nitrito O. So if they are given same compound ONO means nitrito O. If they are given NO2, nitrito N. So please note down this difference is very, very important. And as the complex is cationic, we'll say platinum 2. If it is anionic, we'll say platinate 2. We'll say what? Platinate 2. Suppose if this Cl is outside, definitely we'll say platinate 2. As the Cl is inside and ONO is also inside, NH3 is inside. So we'll say it is cationic complex and it is nitrito O platinum 2. So this is the answer. And for this, the answer is C option. For this, the answer is C option. For this molecule, the answer is this. So please note down. Very, very important. This type of questions you'll expect in the examination. 100% they are going to get, we are going to get questions like this. So whenever they are given the molecule NO2, we have to write nitrito N. If they are given ONO, same NO2, if we have written ONO, we have to write nitrito O. This definition, this difference you should understand. Please note down. Next question. So these are the models based upon important models I have given for this naming of coordination compounds. Now we have to discuss even naming of isomerism also. Isomerism in coordination compounds that we'll discuss in the next session because this 1 hour time is finished. So in next session we'll discuss more about isomerisms. So with this, I'm ending this session. Very, very important. Please follow as and note down this session and do more questions based on nomenclature, that is naming of coordination compounds. After that, in the next session, we'll definitely do the questions based on isomerism, both structural as well as stereoisomerism. So next session is completely based upon isomerisms only. So please note it down. So with this, I'm ending this session. Thank you all.